climatic extremes in Mediterranean climatic regions. Now, Ricardo Trigo graduated from physics, got a master in geophysics, and a PhD in climatology from the Climatic Research Unit of the University of East Anglia at Norwich. Now, the Climatic Research Unit, CRU, is a famous center in climatology that maintains datasets, the CRU datasets, which are the basis of countless climatic analyses carried out around the world. Ricardo Trigo is an associate professor here at the Faculty of Sciences of the University of Lisbon, and also he is director of the Don Luis Institute. His main research activity has been focused on the impacts of different types of weather-driven natural hazards, with particular emphasis on floods, droughts, heat waves, and wildfires, and particularly how these phenomena are related to specific atmospheric circulation patterns, such as the North Atlantic Oscillation, blocking highs, or atmospheric rivers. He has published extensively, often in collaboration with colleagues from different disciplines, and in 2008, he was awarded with the International Journal of Climatology Prize of the Royal Meteorological Society, UK. Please, Professor Trigo, the floor is yours for 50 minutes.
Well, thank you very much for the introduction, and thank you for the organizers for inviting me. It's always dangerous for a group of ecology people to invite a physicist, but that's the danger you have to stick with. So, I'm going to show at the beginning some graphics that I'm sure most of you have seen published in IPCC or other reports, such as this type of changes in average surface temperature at the end of the 21st century, associated with either a very steep increment in greenhouse gases with the RCP 8.5 or not so much, but probably the way the world is evolving, we are closer to this situation in the future than to this one. But in any case, what I would like to emphasize is that you can see an increment in temperature that is larger over the continents than over the ocean. Second, it's much larger over the northern and southern pole than in the tropics. And third, you can see that the signal is coherent throughout the world, so it's the same signal. But if we move to precipitation, you don't see such a coherent signal throughout the world. Independent, if we're in the weak or strong climate change scenario, what you can see is a difference between areas where you have an increment of precipitation in high latitudes and in the equator, and at the same time, areas where you see a decline of precipitation, okay? So this, from the hydrological cycle perspective, it's extremely important. Now, if we stick with the precipitation and hydrological variables, such as precipitation, evaporation, and going to something that is extremely important for ecosystems, runoff, soil moisture, and if we maintain in the higher end of the climate change scenario, what you can see is that this imbalance between precipitation and evaporation means that there are particular areas of the world that I've highlighted here, and that show this imbalance in a particularly striking way. And those are mostly what we consider Mediterranean climate regions. So that encloses the entire Mediterranean, most of southwest states, the Chile coast, the South Africa, and parts of Australia. This is very important, and if you are aware of, in the just last decade, we've seen major drought situations in all of these areas. If you remember 2016 and 17, water was running absent of Cape Town city. In São Paulo and Chile, there's been mega drought situations. In California, I will show you 5-6 years of continuous drought. And of course, I will show most of the work I've been doing in the Mediterranean. But all of these have seen extreme drought situations, either during 1, 2, or 3, 5 years, with enormous human and ecological impacts. Now, one of the main problems here is that besides this direct impact in droughts, you have a secondary impact, which is heat waves. Heat waves nowadays, and I've been studying them for 2 decades, are to a certain extent also consequence of the dryness of these areas. And heat waves together with drying trends imply in most of these areas something that is very important for you, which is fires. Fires are driven by these compounded events of dryness and heat waves that act together. And I will show briefly some of these examples. We had an extreme drought situation in Iberia in 2004 and 2005, and by extreme I mean the most extreme one in most of the areas south of this red color, and in Lisbon for 150 years, and in Madrid as well. So obviously we had quite a large amount of impacts in agriculture, in ecosystems, in hydroelectricity production, okay? As an example, let me show you something that we've published at the time, which represents this very simplified index of vegetation activity that you know, NDVI. And what the colors are showing is the number of months with consecutive negative NDVI anomalies. So this means that all these areas that I've shown you with less than 50% of precipitation during that hydrological year show a large number of months with negative vegetation activity. And 2 years afterwards, a major drought started in the other side of the Mediterranean basin, and we called it this fertile crescent. And at the time, we thought it was a 2-year drought, because after 2 years, using the same color bar, you can see the area that I'm depicting goes from the southern Iraq all the way to Lebanon, enclosing most of Syria, Iraq, and southern Turkey. And you can see by color that you have extremely low precipitation in 2008, 2009. We then realized that 10 years before there was also a similar large drought. So when we pick up all the precipitation for that area, what we can see is that the 2 most intense drought episodes of 2 years occur precisely in the last decade, that is 98-2000, 2007-2009. But apparently when we wrote this in 2010, we didn't realize that the drought was proceeding. So it was a going situation, and this had tremendous impact, as you might expect. Of course, using the same type of approach, we can see a number of months in all this area from Lebanon all the way to Iraq with consecutive months with negative NDVI, both in 2008 and 2009. And more important, as I was saying, the drought didn't stop in 2009, and in fact, in 2010 there was already 1 million refugees inside Syria prior to the start of the war. So this is very important, and this has been studied in high-ranking papers such as this one and others in Nature and Science. We now know that part of the problem with the refugees coming out of the Middle East is due to climate change, okay? And this is extremely important for Europe. Now, in a very simple way, let me show you that the precipitation for Syria is declining, the number of droughts is increasing, but you must see that together with the increment in temperature. If you put those together, then the possibility of major droughts, such as measured by Palmer Drought Index, which is one of the typical drought indices, you see a larger tendency for major drought in recent years than just the one induced by lack of precipitation. This is important for Eastern Mediterranean, it's important for Iberia, it's important for California, it's important for all these semi-arid regions of the world. Droughts are occurring not only in this area, not only because precipitation is declining, but also because evaporation is increasing due to the rise of temperature. And when those two are combined, then the lack of water for plants is increasing. Of course, in this case, the problem was particularly acute due to the increment in population in Syria. And so it's very different to feed 25 million people than to feed 5 million as 50 years before. So this increment, again, compounded a major effect there. So just a few years ago, and to stress again, we were back into a major drought situation in Iberia, 2011 and 2012. Again, if we look into Iberia as a whole, what we can see using Climate Research Unit precipitation, what we can see is that the three major drought events, when we consider the entire Iberian Peninsula, were in fact the last three major events. So 98, 99, 2004, 2005, that I mentioned was the biggest one, 2011, 2012. And when we start to see this clustering of very large episodes at specific periods, we know that something is really happening here. This paper we've published with some colleagues from Oxford, and we use lots of dynamic models, lots of dynamic runs, not models, the model was just one, but models that we can run thousands of times using spare time of people's computers. And what they've shown is that we can only reproduce this increment in large droughts in Iberia if the dynamic models are run with the greenhouse gases emitted in the last century. If we don't use the real greenhouse gases emitted, then this increment in droughts over Iberia will not appear, okay? So this is a signal of something that is already happening, partially due to climate change, okay? This is very important. Of course, all these droughts had major impacts in agricultural production. This is an example of production of wheat and barley, where you can see that these two major droughts I mentioned, 2005 and 2012, you see a drop in the cereal production, both in Portugal and in Spain. And in fact, the 99 one I mentioned, you can see also here. So, what is the panorama over the entire Mediterranean basin? Well, that is shown here. If we pick precipitation within this red rectangle and we compute the evolution since the beginning of the 20th century, what you obtain for the precipitation inside this rectangle is this time series. And you can see, just looking at this plot, that there's a decline in the last few decades. So a number of teams in Europe and in the States run the most comprehensive models with both oceanic and atmospheric components. And again, and this is was run under this CEMIP project, which encloses lots of different models. And the only way to reproduce that type of decline of precipitation that you can see here, both in space and in time, was when those models were incorporating CO2 and greenhouse gases as we know they've been injected into the atmosphere in the last century. So when we run those models without incorporating CO2 and only with natural changes such as solar variability, volcanoes, and so on, we don't see this decline of precipitation in this area, okay? So this is very important because this again is stressing that what we're seeing in this type of Mediterranean areas is already to a certain extent the result of climate change, as models had predicted 20, 30 years ago. So when we see those climate change scenarios, we should put these, we are already in the middle of something that is going on, okay? So that is always important. And picking up in some of the results by a review article led by Wolfgang Kramer, that is here, it is important to look at this also from the temperature perspective. Not only precipitation is declining, but temperature in the Mediterranean area is increasing faster than the global average. And according to models, that is going to be the reality in the coming decades. So there's this divergence between what is happening at the Mediterranean and at the global scale. And again, and I will show in the second part, that this increase is expected to be associated with more frequent heat waves. They've also shown in this quite nice graphic that each degree of warming implies on average less 4% of precipitation, and you can see that here in these, all these gray lines correspond to a different model, and the red line is the average of the models into the future when you compute increased temperature, and you can see that on average that implies a decreased precipitation, particularly in the southern Mediterranean. Right, so while all of this was happening in the Mediterranean, in California, we've seen in the last 2 decades 2 moderate droughts and a huge drought that is confined here to these 4 or 5 years. And in fact, the driest years ever in the last 120 years in California were observed here in 2013-14. And that really had major influence, particularly in the increment of fires and the collapse of agricultural production in some of the areas. You know that most of the agricultural production in United States is coming out of this valley here. And this is the difference of a satellite picture at the beginning of 2014 compared with the same day 1 year before. Unfortunately, there's some clouds here, but you can see that this is much greener all over than here. So in just 1 year, comparing the same day, you can see a huge drop in vegetation activity at the beginning of this year. And that continued for several years, okay? So these had major ecological impacts as well. Now, what is driving this tendency for dryness in California is quite similar to what is driving dryness in Iberia, and we'll see also in Southern Hemisphere. And what is that? In simple terms, without going into much detail, there's a tendency for storm tracks that usually cross here to pick up the jet stream and go northward, and you have a wetter area here in British Columbia and Canada, and much drier in California and part of the Rockies. And this tendency for the jet stream to wobble is also a signal of climate change. Why? Because as temperatures are increasing faster in the northern pole than in the tropics, the temperature gradient between the tropics and the pole is declining. And that temperature gradient is the one that maintains the westerlies at the fixed position and not going northward or southward too much. The more we weaken that temperature gradient, the easiest it is for the storm tracks and the associated jet stream to meander north and south. And that, what we're seeing here, is happening quite often also in Europe, okay? Of course, it's different if you're talking about winter and summer. I don't want to go into details, but basically this tendency to decline the temperature gradient has implications also in dynamics. Right, what about Chile? Well, Chile is the worst case. They are still in drought. It started 10 years ago. Most of the population in Chile, Santiago is here, is living in this central area. Of course, Chile starts here and ends, but most of the population is here. And this graphic shows the decline of precipitation. The zero line is here. It's showing precipitation for each latitude, for each year. And what you can see in this part where population really occupy the land, you can see this tendency for drier than average in 2010, 11, 12, and so on. So all these years, they had lower than average precipitation in Chile. And there's René Garreau is one of the guys really publishing a lot there. And of course, the impacts of these are immense. Just a few examples. While we have this rainfall deficit, and this is just for the first 5 years, you have less load of sediments going into rivers, and of course, less sediment reaching the sea. For example, compare the blue circles in 2008 in these rivers with 2013. There's a huge drop. There's a tendency for a vegetation change as depicted, I believe, by satellites in all this area. And of course, the amount of burn area, if you compare the average for this period with these 5 years, you see a huge increment in Chile. Again, think about increment of temperature together with the drop of precipitation that is inducing all these together. And from the dynamical point of view, it is more or less the same. So Garreau provided here the historical drought fingerprint. Chile is here. So this is the situation for typical droughts where we have a high crossing all the Pacific here and a low with the storm tracks going further south. During these 10-year mega droughts, what you see is this huge increment of pressure and geopotential height in all equatorial and subtropical latitudes, and much lower here. So storm tracks are really passing much to the south than in the usual situation. And this is compounded with sea surface temperatures much higher than during usual droughts. Here is the sea surface temperature anomaly during normal droughts. You see here some positive anomalies, but during these 10-year mega droughts, and of course, sea surface temperatures are increasing anyway. So some of these drivers are there almost on a permanent basis, okay? Right, so much for precipitation and dryness. What is really worrying us here in Europe in the last month is extreme temperatures, okay? We had 2 heat waves in the last month with record-breaking temperatures all over Western Europe. So what is happening in climatological terms? Well, based on this, that is already 8 years old, and this is danger in extreme analysis, you can see all summer northern hemisphere temperature distribution when you remove climatology. So each color here is presenting a 10-year distribution of anomalies for summer northern hemisphere continental stations, okay? So what you see is that during the 50s, 60s, 70s, nothing really important happened. But as we move along the last few decades, you see this tendency towards higher temperatures and particularly much higher extreme temperatures. It is not so much in winter. Of course, in the summer, this is particularly striking because besides the thermodynamical impact, you have the dryness of land that is also increasing this tendency, and you don't have that so much in winter. Now look and imagine the probability of a 3 degrees anomaly 50 years ago and now. And you must imagine that this purple curve is not the current climate. The current climate is somewhere here already, okay? And now compare the probability 50, 60 years ago of a 3 degree anomaly, which would be almost zero, virtually zero, and compare that with what is happening in the last decade. So we've moved from 0 to 5% to 10%, and in a few years it will be 30%, okay? This is important to put in perspective what I'm going to show in terms of major heat waves in the last few years. Of course, 2003 is a major event that is at the back of our mind. For example, and this is important, France, for some reason, they closed schools last month. They were really afraid of a repetition of what happened 15 years ago. And 16 years ago, what happened there was an increment, a doubling of mortality in all these departments around Paris and the Loire Valley. So all this color means a duplication of mortality. And at the time when we look at absolute temperature, maximum temperature for those 15 days, these didn't match well the mortality increment. But of course, when we remove the climatology, that matches much better. And so people are used in their place to the typical distribution. Nowadays, that is very easy to accept. 2 decades ago, it was quite difficult. We had quite a few problems publishing in journals with medical doctors as reviewers, because they were not aware of this difference between 40 degrees impact in Lisbon, in Madrid, or in Paris. That's completely different. In Madrid, it doesn't kill that much. In Lisbon, it kills quite a lot. In Paris, it's a catastrophe. Okay, so it's quite different. So what happened during those 15 days? I'm showing this because, again, you can see this pattern that is similar to what I've shown you in California with the jet stream going up. Okay, but this is summer, and you must imagine that jet stream is going in this around Europe, and you have this intrusion of hot Saharan air coming out of Africa and going into Europe. And in fact, as I will show you later, this is precisely what happened in the last 2 major heat waves. Of course, if you compute the anomaly of temperature in the upper air, this matches pretty well where we've seen the higher levels of mortality. Right, and what about Portugal? You know that Portugal, we have quite a lot of fires. In usual years, it can burn up to 200,000 hectares, but in extreme years such as 2003 and 2005, that was out of scale. 2003, we had more than 5% of the territory burning during the summer. And if you see the colors that correspond to satellite passages, you see that most of it is in red, and red means between 2 of August until 14 of August. So all this reddish area was burned during those 2 weeks, while a lot of people were in Europe, up to 60,000 extra deaths occurred due to this heat wave during these weeks. Right, just a few years afterward, we had another important heat wave in central Mediterranean, and the reason I'm showing this is that it really burned quite different landscapes and land covers, and also to show you that heat waves in Greece or Turkey are related with atmospheric circulation anomalies that are totally different from what is happening in Iberia or France. So you see here an intrusion of hot air coming out of Russia. This is important in terms of what is happening in Western and Eastern Mediterranean. It's very rare to have heat waves occurring at the same time, and even during the same summer in Iberia and Eastern and Central Mediterranean. And the reason for this mismatch is this one. The dynamical mechanisms to produce this type of heat waves are different. This is important when you're responsible for managing airplanes and information at the European level, because you can help countries separately, and you don't need airplanes to go and help Portugal, Spain, southern France, Greece, Croatia, all together at the same time, because usually those huge heat waves will not occur simultaneously in those different places. Right, and afterwards we had the mother of all heat waves up to now, which is this Russian Black Sea heat wave. This is already a bit outside the Mediterranean area, but this was so big, and this is the type of things that we must prepare into the near future, not the long future, that we should study them and be aware of what happened. So in 2010, in August, we had a heat wave that broke all records. So the colors are showing temperature anomalies. All the dots are showing record temperatures compared with the previous 110 years. So a huge period of comparison. And what you see in these ISO lines is the anomaly in standard deviations. So 3 standard deviations is huge. 4 standard deviations is amazingly huge, okay? So 4 standard deviation, and you see these records at the week, 2 weeks, 1 month, and the seasonal time scale. So we picked up all the information we had for a long time in the European window, and I mean really long time. This means to merge data from NASA together with the multi-proxy data that uses old observed data. Fortunately, in Europe, we have observed data since late 17th century, just in a few stations, lots of data in 19th century, but we have proxy data that enables us to produce quite robust reconstructions. And if you use all that data, what you see is that the coldest years are represented here, the warmest years are represented here, and you can see 2007, 6, 2002, 2003 that I mentioned before, and 2010 that is here. And you can see that these two are completely outside the normal distribution curve that is typical of 500 years of data, okay? And I will show you that just the last 10 years since this happened, it's still going up to the right, okay? In fact, we can see that these huge heat wave, or these 3 that I mentioned, 2003, 7, and 10, change the panorama of heat waves and the way we see the warmest summers in Europe. If you pick these 500 years finishing in the year 2000, and you pick up the color, it is showing when the warmest summers occur in Europe, okay? And the height of the bars indicate the anomaly, let's say. If you introduce the last 10 or the first 10 years of the 21st century, you see a huge change in color and altitude of the bars. And of course, all of these is due to the 2003 heat wave. All of these here in Greece and Turkey to the 2007, and here to the 2010. And while this is great, I must tell you that the last 10 years have changed this dramatically. I have no time to show you, but basically in the last 10 years, most of these is now red again, okay? We're still computing stuff, but basically all the warmest summers in the last 520 years are happening in the last 20. Basically, okay? For those of you that don't like to mix good observed data with proxy data, this is the same graphic, just with observed data until 1880, and you can see basically the same. The first 10 years of the 21st century changed dramatically this picture just by changing here 2000 to 2010. So, what was the impact of these 2 major heat waves in net primary production in Europe? Well, if we look into Western Europe, of course, 2003 implies a major drop while in Eastern Europe, 2010 is the real king of all drops in net primary production. So this is for this part, and this is for this part. And we compare that with the typical cycle of net primary production for the amount of years we had at the time, I don't remember. And we can see here the months where this drop was particularly significant in each of these heat waves. And we're doing that on a regular basis for all these major heat waves. So finally, what is happening in the last few years? In the last few years, we are observing an acceleration of all these processes. So 2017, unfortunately, Portugal suffered a fire season that was even worse than 2003 and 2005. Why? Well, all of these burn. Please bear in mind that in Portugal, it's not the hottest places that burn. The hottest places are here. It burns in places that are not fuel limited. We have lots of vegetation north of the river Tagus, and that is a very important issue. Many people, even in Portugal, are not totally aware. They keep asking why Portugal burns. Well, Portugal burns because we have lots of vegetation, and this is a mixture of Mediterranean type of climate with Atlantic type of climate, in fact. And so there's a big difference in vegetation in the northern part and the southern part, and we have lots of fuel in the northern part. Right, each color represents a different month, and what is amazing here is that the catastrophe we had took place before the season, fire season, the official one, which is July, August, and September. So we had 65 deaths during this week, and we had another 50 deaths just during 2 days in October. So prior and after the fire season, we had these major heat waves that killed lots of people, okay? And let me remind you that in the following year, Greece had something similar with about 100 extra people dying. So let's see what happened specifically in those two situations, June and October. In June, we had a major heat wave, but striking only Iberia and southern France, with record temperatures at the global Iberian scale, particularly for June. And how do we see that? Well, I have here all the anomalies at the 7-day scale. So let's see all the weekly anomalies for June, July, and August. And if you, well, the colors are not the best ones, but June is in red, and all the anomalies are shown here. The line is representing what happened during that week where we had the fires in Portugal, okay? So really outside the distribution for 70 years of weekly anomalies. The blue and green that we cannot see very well are the same for July and August. And what you can see is that this incredible week during June in 2017 was very similar to the hottest weeks in Iberia for July and August, when it's really the peak of summer. This is something also that is a typical implication of climate change. The summer is enlarging, okay? So June is becoming similar to the rest of the summer. And think about what happened this year again. We had major heat waves in all of Europe in June and beginning of July, okay? So this was for middle June and October. What was happening in October when during those, in fact it's not 2 days, it's 1 day and a half, we had the fastest rates of burning area in all the world. So this is faster than the fastest fires in California or Chile or Australia. The fastest rates occur during 16 and 17 of October here. So why? Well, we had the temperatures were high, but the Palmer drought index or any drought index, let me show you. Remember 2004 and 5, was a major drought, yes. It reached 100% of the territory. 2011, 2012 that I mentioned before, again, it reached all the territory in the two most important classes. In 2017, we had, in June, when we had the first fires, 80% of the territory was under drought. In October, 100%. So it was hot, it was extremely dry, and then we had the third component, not very usual, which was a tropical storm passing close to the coast. So of course, this was one of the main dynamical reasons for having these very fast burning rates. But what is really important here for you the takeaway message is all of these three components are being changed, induced, increased by climate change. Dryness, heat wave, and the possibility of cyclones, tropical cyclones, close at these latitudes. Of course, these tropical cyclones, when they travel really fast, and when they reach our latitudes, they quickly change to extratropical, and they lose this high and this very perfect symmetrical shape. But that's not the relevant thing. The relevant thing is that in the last 2 years, we had 2 tropical cyclones striking Portugal. One was responsible for this, and exactly 1 year after, 2018, during the same days, October, we had a tropical cyclone striking Portugal, really, with winds up to 200 kilometers per hour. Okay? And prior to that, the number of tropical cyclones is really ridiculously low, let's say. So this is changing fast, and we know from our colleagues in the United States where this is really a problem, that the number of tropical cyclones is increasing in northern latitudes, which is a big problem for them, but apparently it can be also a problem for us. Right, and to finalize, what happened last year? Well, last year, first let me show, we like to use a dynamical way of defining what is a Saharan air. We use some objective measure, and we can enclose these in this isoline. At the beginning of August 2018, we had a huge heat wave striking only Western Iberia and Portugal with this intrusion of Saharan air. This was exactly 1 year ago, at the beginning of August, but it was sufficient to break all the records in Portugal. And for you to have an idea, Lisbon, the previous record was 42 degrees in the last 150 years, and it became 44 degrees. This was 1 year ago. And when we were writing a paper on this, just one month, last month, we had this major heat wave striking France, and the record temperature in France changed from 44.1 that was observed in 2003 heat wave to 45.9 close to Montpellier. I don't know if this, Wolfgang, is this official, this record?
Yes.
Yeah. So this is a huge increment, similar to the one in Portugal, so about 2 degrees in just one go. This is not typical of new records. Typically, new records are half a degree, something like that, not 2 degrees, particularly in long records. Right, and going back to the figure I've shown you just half an hour ago, when we were looking at 2003, 2010 heat waves, let's see how these has changed. Well, 2016, that was not there before. 2003 is here, 2010 and 2018. And I would almost bet that 2019 will follow somewhere close. It could be above even, because we had already 2 heat waves. So, not sure, it depends on many other factors, how August will develop. But it will never be too far away from these 2 here. So this really shows how things are moving really fast, and how this tendency for heat waves is happening at a faster pace than we thought just a few years ago. Okay? To be honest, I'm really impressed with what is happening. Not only at the global scale, we had 2014, the hottest year ever by a small margin. A year after, again, a record at the global scale, and 2016, a huge record at the global scale. And in Europe, we're seeing this on an annual basis. So I never thought that we could see climate change happening in real time in front of us, but that is what is happening, basically. Right, so some takeaway message. The Mediterranean climate regions, all of them, are getting drier, and drought frequency is bound to increase during the current century. Recent mega heat waves in Europe, such as 2003, 10, and 2019, have been outstanding, not just at the weekly, but monthly and seasonal scales. This is why they then appear when we compute the entire season. There is a growing tendency for complex compounding events in all Mediterranean climate regions. Let me call your attention, there's a cost action that is starting now with compounding events, and that is mixing particularly drought, heat waves and fires, but also storms, floods, and all of those are really important for ecosystems. All of these, because we cannot compute return periods just for one, but we must take into account the simultaneous occurrence of both. So when you're looking at the effects of heat waves or droughts into ecosystems functioning, you must take into account that you should not evaluate those independently, but also when things occur simultaneously, because the return period might be less than what you think when you put those together. And most regional climate models predict more intense heat waves and drought episodes for the Mediterranean basin, but also for the other Mediterranean climate regions. And that's it. Thank you.
Thank you for presenting this very unpleasant climatic panorama of the Mediterranean world and the surroundings. So, questions, please.
Thank you for your nice talk, a little bit terrifying.
Oh.
Although we feel that the climate is changing, it's really amazing to see this supported by models. As a person that is working in ecology, I would like to know what we can do based on these, not scenarios, but what is happening all over the world. What can we do as ecologists? Can we do something to mitigate these effects, or we just be here looking to this terrifying movie and waiting for a better future? Thank you.
First of all, it's not my intention to provide terrifying message. Things are the way things are. To put this in a broader context, I would probably believe that there are other issues currently that are probably more important than climate change at the shorter time scales, such as plastics in the ocean and the collapse of some insects and some other stuff that is happening at a very fast rate. So at the time scale of a few decades, climate change is really, really impressive. But despite this, I believe that we have some capacity to adapt. I'm not entirely sure, and probably because I'm a physicist, that we are capable of adapting to the amount of plastic that we are eating in the short term. So to put things in a perspective, probably there are other issues happening currently that are as important, at least. But to be honest, I don't think there is much we can do. We can influence the amount of greenhouse gases that we're going to put into the atmosphere in the coming years and decades. Looking at how things move so slowly in the last few years, for example, in 2015-16, there was apparently a drop or a stabilization of the amount of new CO2 into the atmosphere, but that has increased in the last 2-3 years. the capacity we have to change that, where at the same time we have all these people in China, in India, that are trying to obtain same level of life that we have in Western Europe and States and other countries, it's very difficult to change. So I'm not very optimistic in the way we can, unless there is something providing a new discovery like fusion, electricity, and I'm not sure that we can change these in the short term, unfortunately.
Yeah, thank you, Ricardo. It was a very good talk. I would like to argue a little bit about the forest fire that I know you've worked on in a number of papers, and of course nobody questions the importance and the intensity of the recent forest fires, but the attribution of them is a very complex case for every one of them. Right? For example, the decline of agropastoralism in all of the Mediterranean is basically the reason why there is so much vegetation out there.
That is the basic reason.
Right, and then there are additional things. For example, the French army a few years ago, they performed a lot of testing with I don't know, some new sorts of missiles in the driest season, and they created a big forest fire from that. In southern France, I'm told by the experts that 9 out of 10 forest fires are lit either by firefighters themselves in a criminal action or by accident from people throwing away cigarettes in places and times where this shouldn't be. So, I mean, the system is out of stability from an ecological point of view, and the additional stress that comes on it from the drought and from the heat that you describe is important, but how important is it? How big is the role of climate change in the increase of forest fires in the Mediterranean?
Definitely what you're saying about the decline of usage of the forest and the decline of the population. That in Portugal took place a little bit after what happened in southern France, Italy, and that is really the major driving force. And again, most of the fires that have been studied in Portugal are related with human action. The fraction due to arson and to negligence changes over time, and even the definition of negligence, it's not totally clear. For example, power lines that we know vegetation should be cut every few years underneath. If they don't do it, is negligence or arson? The definition is changing because some of the people responsible for that in Portugal are going to trial now for some of the fires in the last few years. So, but basically 90 to 95 or even more are due to human action. One thing very different is the perspective from, let's say, a geographer, which is how do you explain the fires where they are happening? From that perspective, human occupation, roads, electric power lines, all of that are the main predictors that explain especially up to 95% of the variance. That has been studied for Portugal and it's similar to other. Now what we're talking about is temporal variability. If you're talking about temporal variability, you must think of, in Portugal you have thousands of people producing fires every day. A few of them are arson, but I would say that the majority is negligence. Stochastically, you have people doing bad things all over. But why do you see some of these fires, like we had last week, that grow out of control? That is mostly due to climate. From that perspective, if you have a higher frequency of heat waves together with dryness, then that increases the burn area associated.
So with respect to your last answer and the answer to the first question, this is a naive meteorological question, which is, at what temporal scale are we able to predict the arrival of these mega heat waves? Because if at least we have a little bit of head start time, we can put in mitigation measures, you know, for example, banning people from going in certain areas and taking cigarette lighters and things with them and all that kind of stuff.
Mega heat waves, you can predict them correctly with a week, which is quite good nowadays. But it's also important, and we're doing that with companies here and with National Civil Protection here, because fires here are so dependent on the amount of rainfall in winter and the climate conditions during spring. When we reach the beginning of June, in our group, we can provide a forecast tool of what is going to be this coming year. If it's going to be above the average, below the average, what are the probabilities of that happening? For example, in 2017, we were in a meeting with a company that is paying us some of this stuff, and we told them on the 5th of June, this is going to be a really above year in terms of burn area, and was. And in 2018, that was probably even more interesting, because it rained a lot during spring. We knew that even with a heat wave that could occur, it was going to be a year below average. And so that was the kind of forecast we provide, long-term forecast. And we had the strongest heat wave, as I mentioned, at the beginning of August 2018. And in the middle of that heat wave, one of my colleagues was on TV saying it's going to be a year below average. Because we knew that fires on the average, the total burn area in Portugal depends a lot on these compounding effects of spring together with the heat waves. And because spring pushed everything so much lower, even with a heat wave, things would be lower. But that was a tricky one, and we had a major fire in Algarve. But in 2017, we had more than 500,000 hectares, and in 2018, we had 40,000 hectares.
Thank you very much. You said at the end of your talk that you were surprised to see climate change happening live. That's a strong statement from, I'm sure you're not the only climate specialist to say that.
And the type of statement that I would never say 5 years ago.
Yeah. What are the technical aspects or reasons that you think, from your point of view, that we missed 5 or even more years ago, and that we did not see, and that comes to this conclusion?
Several. One is that when you look into distribution, the changes in the average of 50 percentile go slower than the 70 percentile, the 90 percentile, and the 99 percentile. So in these typical changes of temperature distribution, as I've shown before, the changes in the 99 percentile are much faster than the other ones. And the capacity to attribute that to climate change is really much higher than some of the others. So when 20 years ago we were looking into changes that are compatible with what we've seen in the Mediterranean regions, we did not realize at the time that changes, we knew that extremes were different, but we didn't realize that changes would be really faster than on the average. That's one thing. The other thing, more structural, was, you know, that during a period of 10 years, the first 10 years of the 21st century, the global temperature didn't rise that much. So we had the El Nino in 98, and then only in 2014, 15, and 16, temperature got up to the same rise that it was going before that hiatus in climate change. The reason for that apparent hiatus, that is not a hiatus at all, when we look into the last 60 years, it's you can see a straight line going up. The reason for that apparent hiatus was a huge amount of energy that is going into deep ocean. And the capacity of dynamical models to model and incorporate those components, it's not just El Nino, it's other stuff that is happening at slower scales and is putting most of the energy into deep ocean, okay? And that means that 20 years ago, models were not good enough to include those components, and nowadays they are. So models now can reproduce that type of variability, and they can reproduce that apparent lack of increment of temperature. But 20 years ago, they were not able. So things are improving both from the dynamical perspective and from the statistical one.
And very last quick question from you.
Thank you for this opportunity. Very quickly, from a practical perspective and applied ecological perspective, I'm busy with a very large restoration project in the area that burnt in Algarve, in the Montchique area. We are trying to recover natural habitats. My question to you is quite succinct, because we're dealing in a small contextual aspect, and a lot of the science we have is very global and regional, and it doesn't apply. It's very difficult to apply it into a small context. So I'm working with Miguel Araujo and his team, and trying to understand how we apply what you guys are finding out for us who are putting the vegetation back in the ground, from the fire aspect, and understanding all the other contributing factors, the drivers, because we've got lots of land degradation in this area. And trying to understand how because we are looking into the future, we're putting something in the ground that's going to be there for 20, 30 years. And how do we apply the concepts of reference or novel ecosystems, because we don't have anything to go on. The 2003 fires destroyed everything. They hasn't recovered, because what has happened is the change in land use has been more to monoculture than back into the original vegetation. So people took the opportunity, my land burnt, let me just plant eucalyptus. So we have a river basin that is a Natura 2000 area, 90% under the classification, that has 46% eucalyptus in it. The eucalyptus burnt.
But it was burned in 2018?
2018, and I'm doing research in that area at the moment. It hasn't returned. There's been very little regrowth in that area. And so we are going in to do assisted recovery, but we're stuck with one of the difficulties of how do we do assisted recovery and take into consideration all the other driving factors that are coming into play. And of course, sitting at a table, everybody has a different opinion. And I would like to understand, obviously working with Miguel and Diogo Alagador, and various other people, we are trying to take the theory and put it into practice. And so my question here is, how do we create this link when we're dealing very much from a global or a regional perspective on climate change, and suddenly we have local contexts where we come down to hectares and not thousands of hectares of areas, and specifically in little areas like this river basin, which has an Atlantic influence, has big mountains, 900 meters on the landward side, and slopes that are over 42 degrees in aspect, as well as north-south, east-west aspects. So from an ecological perspective, it becomes very difficult to try and model or design recovery processes.
That's very easy to answer. I really have no idea.
Good. Thank you very much.
Okay. Thank you very much, Ricardo. Thank you everybody for being here and for contributing to this session. Thank you.
sì. So we need to move to the next speaker. So it's my pleasure to introduce Mark Moretti. So we are changing of topic. We are changing from the climate change topic to the urban sustainability, which in fact they are more or less related in a way that we know that one of the causes of fires is not only climate change, as we have listened, it's also human action. And one of the human actions is to move from rural landscapes to cities. And as you know, the projections are that a bigger part of the population will be in cities. So urban sustainability is also a hot topic nowadays. And Marco Moretti, which is a community ecologist working at the Swiss Federal Research Institute in Zurich, is also a member of the Swiss Biodiversity Forum and of UrboBioNet, the Urban Biodiversity Research Coordination Network. So in urban ecology, Marco leads trans and interdisciplinary projects on the ecological and social values of urban nature by collaborating with ecologists, social scientists, and psychologists. In particular, he investigates direct and indirect effects of social and ecological drivers on ecosystem processes and services, and tests if and how these are mediated by changes in biodiversity and trophic interactions. So Marco, the floor is yours. Thank you.
A lot. Good morning, everyone. I hope to give you a more positive message at the end of the presentation. But of course, I mean, reality is whatever. So my talk is about socio-ecological drivers of biodiversity and ecosystem functions and service in cities. I like to start my presentation by showing how the perspective or the perception of cities has changed through times. Not only among people, but also among scientists. And this is a bit striking because scientists are supposed to be more objective and not too much involved in emotions. But until the 70s, I would say that cities were seen as something very bad, not a place to live. Nature was outside cities, and cities eventually to work, but not really to spend free time. But suddenly, 10 years ago, 20 years ago more, so suddenly cities are become green, place to live, life of quality is a keywords among this. So also publication has raised dramatically since 2000 with several books, very good papers, not only relegated to topic journals, but also in really journals that really demonstrate that this is a universal topic. So I like, I like also to show that, to say that also the approach that ecologists, urban ecology through time has changed. In the 70s was very much driven by ecology in the city, where humans were excluded. Only cities were seen as a lab, open space lab, where actually the single items were studied, isolated, not very much in interaction. Then through times, I mean, this is still valid, is a science which is still valid and interesting to understand through experimental approach what happens. But then with the ecology of the cities, we moved to a more holistic approach, more integrative, where human needs and perception was integrated in among the rest. And the last, maybe in terms of time, was how moving science as part of a network of actors and stakeholders, including public, business, urban planners, etc. And these three, as I said, these three approaches are still valid. So this should actually help us to understand this dichotomy, this trade-off, facing increasing population, urban population living in cities, and challenging the life or quality of people and securities, but also taking the responsibility about nature conservation also in cities. It's not because the cities is mainly grey that we can say, okay, oops, we cannot protect species. Since cities are growing exponentially, and since also, as it was pointed out yesterday, most of the cities are in hotspots of biodiversity. We cannot forget this point. And this can be resolved through connection to nature, more experience with nature, environmental education, and positive attitude. So I will take this and try to build up my talk, starting with what I learned as an ecologist before moving to cities. I mean, ecology gave us a nice framework, which is the community assemblage rules. If you want to understand why some certain species are living in a certain place, actually is starting from a species regional pool. Actually is we learned that there's a series of abiotic and biotic filtering that filter out species. But usually this approach or this framework that does not include human. People like Myla Aronson reworked these assemblage rules, integrate. So actually using the same principle of species that needs to reach cities by traveling across space, and cities as one of the major filters with historical legacy, abiotic conditions, fragmentation, habitat loss, but including also the human component with their needs, their expectation about plants and nature, also driven by publicity, by advertisement, Google. I mean, everything influence their choice why they put some plants and not, or maybe also education or what they learned from school. So I also like the framework by Swan, more within cities, saying something like, okay, if we have habitats which are low managed, so the socio-economical influence is low, like brownfields, or on the opposite, you have a very highly managed habitat. This will lead to different processes. Here will be more self-assembly of species, of local species and community, and this will be more facilitated by human. And the interaction of these two will give up our biodiversity and our diversity we observe often in cities. Of course, at the end of this, I mean, the species that we found in the cities will provide our processes and our ecosystem services. Okay, so based on that, I will outline now my questions. And one of the questions is how much diversity is in urban gardens? And what are the factors driving biodiversity and ecosystem function there? And are social cultural aspects involved in this? And does biodiversity play a role for gardens' well-being and restoration? And can we influence actually human attitude to change their attitude towards biodiversity? So then we'll end up with some summary and perspective. But and I will take most of my presentation will inspire by this Better Garden project, which is has been funded for the last 4 years, and which is very interdisciplinary and transdisciplinary project involving people from the councils and stakeholders, but mainly questioning what are the factors influencing gardening behavior. So is there like a policy, regulations, social norms, attitudes, perceived behavior, and how these actions afterwards, my choice, cascade into outcomes of gardens, of well-being, or below and above ground biodiversity and ecosystem processes. So actually, we use traditional methods to sample fauna and flora. So I'm an ecologist, so I'm trained on this. And we applied some ecosystem services, pest control, pollination, and wild bees fitness interactions. The same for below ground. We digged in the ground and used litter decomposition as a proxy for organic matter decomposition. And of course, people were questioned through questionnaires about their life quality and restorations. I anticipated urban gardens. Actually, we used gardens, urban gardens, as model systems, both domestic gardens and allotment gardens. Since these are driven by different kind of people, you can relate to education, to incomes, to accessibility to green spaces. And we had something like 85 gardens in Zurich. We didn't have multiple cities because, I mean, a city is already complex enough if we want to deal with the local and landscape aspects. And so the first question was how much biodiversity is there, and what are the factors driving biodiversity and ecosystem functions, and are social, ecological, cultural aspects involved. So first of all, how much biodiversity? So considering plants, we found more than 1,000 species of plants, both indigenous and exotic or cultivated by people, selected by people. They put what they like. But these are there for pollinators, for herbivores. So we are not looking only at native species and excluding the rest, which is 1,000 species is a lot, I tell you. But last but not least, we found also very rare species, endangered species, and conservation concerns in Switzerland, which means that regarding conservation and responsibility, there is some margin of maneuver. And the factors that driven this biodiversity is some are easy to understand and were like according to our expectation, like the surface. The more surface you have, so with the Highland theory, the more species. The number of habitats you have in a garden. So do you have flower bed, do you have vegetable bed, or only lawn, will influence also, and management intensity will negatively affect. A little bit less understand is the green age. I would have expected that with age something gets older and more complex, more integrated, more micro climates, micro habitats. And what about animals? So we also found more than 1,000 species of animals across different trophic levels and multiple taxa. And actually, just this is not to go into details, just to see which were the dominated pollinators. Snails were doing less good. But I mean, these are remarkable number of species, which maybe nature area would have, but not intensive agricultural land. So, and this amount of arthropods biodiversity, so invertebrates species richness, actually is mainly driven by, or there is a positive correlation between plant species richness and insects or invertebrate biodiversity. And this already says something about this, because who cultivated the plants, who decided which plants is human. I mean, is the citizen who are the gardeners that own the gardens. So what are the drivers actually of total invertebrate species richness. So for this, we run structural equation models, which allow to investigate direct and indirect effects. So management intensity, we have seen influence plant diversity, but also garden size and flower beds. Especially if you have flower beds, you are likely to have more species. And then we have a landscape aspect. So is it a private garden or is it allotment gardens? And how much is the habitat loss in the surrounding? And of course, what we are interested in now is the gardeners. Their attitude to biodiversity. Do they care about biodiversity in general and in their gardens? So through these questionnaires, and how high is their education? So these two factors influence negatively the management intensity. The higher you are educated, the less maybe because you don't have time, you have to teach or to busy with the work. But also your general positive attitude towards biodiversity, given by your education on one side, but also your background, is influenced negatively. And management intensity, of course, influences negatively the total biodiversity, but plants diversity and through indirect effect, plant diversity influenced positively species richness. This is something that we have seen before. And it seems like home gardens are more likely to have less species. And of course, habitat loss in the surrounding is also negatively affecting something local. So what about ecosystem processes and functions? So I concentrated on two, pollination and leaf litter decomposition. So for pollination, we run pollination experiments. Since gardens are so diverse, it was difficult to standardize the methods without using phytometers plants. So plants that actually are the same in all the gardens. And we put 6 plants per species, and we maximize the diversity, functional diversity of this, from the carrots to the something more specific for long-tongue bees. The radish is also similar to carrots, easy to pollinate it, and this is the Symphytum, very much bumblebees species, because it needs also long tongues. So, and we put this in different contexts, as was the design in very intensively managed gardens, but also in very diverse gardens, where you barely see our experiments. And this graph shows that a general pattern for all species, the more pollination abundance, the more pollination individuals you have, the more plant reproductive success, so number of seeds per plant. This is fine. I mean, I'm released that this also works in cities. It's not like flat or nothing happens. This graph shows in the context of the landscape surrounding. So from actually these big pictures, this strange picture comes from LiDAR images. So we could, Zurich is one of the cities which is really scanned by laser every few years. So we could really have a high resolution in the structures. So this is the gradient, urban gradient, based on laser scanning. And this is the distribution of the daily pollination capture rate. So actually, when we did these experiments, we stayed there for 9 hours during 3 days, sampling all the species and dividing by hours. So, these 2 lines shows what's happening in a garden-rich vegetation and or in a garden-poor vegetation. You see for individuals and species the contribution of having gardening more diverse, can contribute to have some more bees. But this decline is along the urbanization is in general happening. And this also for hoverflies, even more dramatically. Here the contribution of a high diverse garden is not seen, and in general for all pollination you see slightly in number of individual contribution of having more diverse gardens, but what happens here is much more strong. And of course this end up to have along these gradients decline in reproduction success, seed production by all plants. So what happened with the composition? We used litter bags to decompose litter, different litter, and we tried to understand whether along spatial scales of factors from the surrounding of the cities to the garden scale, to the plot scale, whether these are influencing directly or whether the biotic aspect or the biotic components were mediated by these factors. And what we found is that urban warming or urban densification is directly affecting the composition positively. You would wonder why. I think it's more related to biochemistry. So the more warm, the more you speed up the biochemical processes. And also land use in terms of having different type of habitat inside of your gardens. The more you have, the more you have the composition. But then you have also direct effect of species richness and microbial activities, which were mediated by species richness positively. This is a heavy metal, which affect negatively species richness, and bacterial, of course, microbial activity. So we see that there are some components related to human, which is a land use type, number of species of plants, and also for multiple soil multiple functionality. It seems like there are direct effect of the choice of people to have more vegetables versus more flowers, and but also this with a negative effect on multiple functionality when you have only vegetable, but also an effect, an indirect effect mediated by biomass, fauna, and diversity of soil fauna on these multiple soil functions. So the next question is, does biodiversity play a role for gardeners' well-being, and can we influence human attitudes? So I bring this graph, even though I'm not a sociologist. This was done by Chris Young during his PhD, postdoc. But I would just address or focus, like you to focus on this. So numbers plant species affecting perceived restorativeness, which affect self-reported restorations, in amount that also other factors influence. But also gardens type. I mean, if you work in an allotment, your perceivedness of restoration is much higher than if you are at home. At home, it seems like, this is a negative for allotment, but positive for home gardens. It seems like having a garden at home, it produces you a bit of stress, because, I mean, you have the garden always there, and you look at it every day, and you say, oh, I have to do this, and I have to do that, and if someone comes, will see my garden. If you have your garden outside, you have also this feeling to be away, to be a bit on holiday, and you do also your garden. So this stress is not there when you have an allotment. It's rather negative. And of course, this stress is also influencing negatively, or actually would be positively, your the stress is influencing negatively the feeling of being restored by gardening. So, but since biodiversity is so important for your self-restorations and well-being, how are people able to estimate their biodiversity? So, of course, they buy plants, they plant, but are they able to quantify biodiversity in their own gardens? So we actually asked, to estimate how is their lawn, their meadows, if they have a meadows or a flower bed, is more like this, or their vegetable bed. And also we asked to quantify, to cross, which structure do they have? Do they have a pond? Do they have dry walls? Do they have berries? All these elements we know contribute to biodiversity. And actually, we have our estimation. So the botanist went out and knows how many plant species, how many native, how many cultivated, how many spontaneous plants there are, and we looked in which extent the estimation of people was correlated positively with what we read there. So actually by crossing this, they were able to estimate well the amount of biodiversity, but not for spontaneous plants. This is understandable. But when it comes to describe the structures, all the structures is also positively correlated with the number of species and also with the spontaneous species. So by using these simple methods, now we could actually run more national-wise expertise to understand how diverse are the gardens across Switzerland or Europe. So what is the link between biodiversity needs and perception and biodiversity? Actually, this was part of an older project, Biodiversity, where we asked people to express their feeling about some pictures. And some of these pictures were modified, just adding elements that we know we are negatively affecting biodiversity, so management, structure, and many, many others. And actually, the best, the one that people most selected was this one. Actually, nothing comparable to what city managers or park managers offer to us, more structures, rich. And these we know are more or less, this 60% of the answer fit very well, or rather well, with what biodiversity needs in terms of nesting, feeding habitats, and so on and so forth. So, but people still seems to be afraid by biodiversity. I mean, if you have ants or spiders, people, even they manage their gardens in a very beautiful way, they still have some, and then this is also driven by our social world. So how can we approach this appreciation by people of their green space and suitable habitat for biodiversity? How can we increase this overlap? Actually, maybe flagship species could help in this sense. The panda of WWF is one of these flag species, but not really something that realistic for us. So we would like to have some flagship species which has some ecological meaning. So actually we were focusing on indicator species of biodiversity. And on the other hand, charismatic species to people. And if you found something in between, this could be our flagship species. So we tried just in a small case study based on birds. So through this questionnaire, we got to know which were the indicators for charismatic species to people. Birds has to be colorful, compatible, not creating damage. Indigenous, better than exotic. Common, so I have to see it frequently. And known, I have to know in, and not something that I don't know the name. On the other hand, so we tested all our bird species, and for a positive correlation with the overall biodiversity of insects and plants, and we end up with these species. And some are colorful, some are less colorful, and you guess that our flagship species was the red woodpeckers, because it was mainly colorful and compatible. It fit actually this. So, okay, nice. But can a flagship species change our attitude? So we ran a second survey in the 3 cities of Zurich, of Switzerland, asking first about this green space, the structure, to just have an idea what they like. Again, not only national, but also cities-wise. And then we split the forms, the questionnaire in 3. 1/3 of the people got to know that the improvement of these gardens and the effort and the money will be for this species. They don't know it's a flagship species. They just have this information. Another 1/3 got this bug, and another nothing, just managing and spending money for something nice. And of course, this graph showed the acceptance. If you don't have any information, your acceptance to use money to manage is proportional to how do you like the different habitat type or the different greens. It increased a little bit if you know there is an insect or biodiversity living there, but it increased dramatically if something more appealing to your expectation, more charismatic is described. What about spending money? Nobody is happy about spending money, even not 10 euros. So this is the willingness to pay. Okay, I can pay, but I'm not happy. If you ask me to spend more than 50 euro, I'm not happy at all. This without any information. But what happens if I get some additional information about why I'm doing this? Is it for a bug? Is it for a more charismatic species? And this unhappiness start to decrease. I'm more willing to spend money on this. So, synthesis and perspectives. Urban ecosystem harbor a relatively high number of species, and this is according to many new recent papers. Of course, it needs space. It needs, so the question I addressed to Laura yesterday was land sparing, land sharing. This is a big problem. How much can we densify our cities in order to have still a good life and space for biodiversity, which is influence indirectly our life? And human expectation and the attitude do have an effect on biodiversity and ecosystems service delivery. And this will very much depending on the perception, experience, education. And it seems there is a quite clear link between biodiversity and city dwellers restorations. But this, has to be still to dig. We are just starting to integrating biodiversity, so elements from different disciplines into single models. Because also we speak different languages, and sometimes it's difficult. When I talk about communities, thinking animals and plants, sociologists think about community of people. So this simple, is create at the beginning a very, very huge problem. And flagship species concept seems to help or can help to interact with partners, with stakeholders, and to make biodiversity more accepted by people in general. So this is, was my last question, my last slides, and thank you for your attention.
Thank you for your talk. I have a question about the peri-urban areas that are not so managed in many times, and the attitudes of people of these areas sometimes are bad, or that there are neglected areas, but many times is the place where we could find a lot of habitats or valuable habitats. Do you have seen some aspect of these areas, or?
Are you referring to brownfields or rural places, or this?
No, brownfields or brownfields, of course, but abandoned agricultural areas, or areas that is I'm referring to the rural to urban interface.
Mm-hmm. Okay. No. So I would say these are very interesting habitat type, because they host a more pioneer and type of fauna and flora. I wouldn't focus and protect this. I mean, we have to understand the urban as like a patch dynamic system, and more like a mosaic that change through times and space. So, of course, if you can, but I mean, what it means managing brownfields, you have still to manage, otherwise it will turn out to be like bushes and at the end forests, or kind of forests, which still, I mean, is interesting. But usually these lands are so valuable in terms of economics, that they will, I mean, I would put more effort in the education, and more, like if some buildings will occur there, that some amount of green will be left. I mean, you have some restriction how, the distance between buildings, and often this space is like lost, is like a no man's land. We can do more to interconnect greens using these spaces. Yeah.
Thank you.
Hello, thank you for your talk. I was thinking about two other places that that are more rare at the moment, which would be something like, for example, did you check about vertical gardens? So vertical green spaces, which are on the rise, and it's interesting because I think there's little work done on the biodiversity there. And did you check any community gardens? So gardens that are allotment gardens, but they are not managed by single persons, but by groups of people, and how does that change in terms of biodiversity?
Regarding verticals, if green roofs are part of them, yes, we did work on this. They are also quite amazing habitat. But we were more interested in to understand whether green roofs can help to make cities more permeable. So whether they interact also with the ground. So brownfield in the ground, and actually for flying insects like bees, it works. The communities are connected with other green roofs, but also with below, but not for spiders, carabids, and not flying insects. So they remains very interesting islands, but not really very functional in terms of connectivity. And the other question was community gardens. No, I mean, as in Switzerland, there is this quite traditional to have everyone has his lot. It will be, I mean, but the next generation of gardens will necessarily be more common community gardens, and there will be some opposition by people because they have their, I mean, they reproduce what they have at home in the gardens. They are not It's a public land, but it's not accessible to everyone because of stolen. They fear damage. So is a bit a strange situation, but of course they are very valuable in terms of biodiversity and contribution to, yeah.
Okay, sorry. Thank you, Marco, for your talk. Don't you think flagship species can be seen as a first step? I mean, they do really make biodiversity more acceptable. If you go to someone and say, okay, save the woodpecker, it's okay for everyone, but if you, this doesn't mean that people are able to appreciate, for instance, bugs. I don't know if you guided my question.
Mm-hmm. Yeah, I mean, these flagship species are first of all umbrella species, so where they also occur many other species, and then you stop talking about spiders and of course, I mean, the end goal is that everyone accept also biodiversity, which is more not nice to see, but we try to avoid and to use these species to go further with the discussion. I mean, it's no point to stop and say, but not ants, but yes, bees. So I think we have the time is too short to spend time in this. If we have like a representative that can make our job, it's fine. In certain circumstances where there are tensions, and so I mean, it's much better to have a positive flag than fighting just for you know, this yes, this no, yeah. But of course, I mean, it would be nice.
Thank you very much. There is a question there.
Hi.
Yep.
Thank you for your talk. It's very interesting. And do you think we can influence really with politics the use or the development of more biodiversity in the garden? I mean, from politics, can we try to influence this strongly?
Yeah, I'm a bit biased. I mean, we have a very nice direct democracy in Switzerland, so we vote every month for, I don't know, maybe 5 or 6 items. Since people seem to have quite clear idea what they want in terms of parks and management, their voice could influence quite a bit politicians. And yes, I think depending on the context, maybe political context, you can influence. Yep.
Is there? Okay.
Thank you for your interesting talk. Two questions. Did you compare your results to the Asian mega city cities, and how does it compare? And the other side of the coin of this urbanization is more abandoned land.
The what? Sorry.
The other side of the fact that people are going to live more and more in cities is also more abandoned land. Mm-hmm. So how do you relate this in this urban ecology concept?
No, I mean, I would dream to go in some mega cities and do this work. I'm trying to do it via collaborations, but not so far. I mean, up to now we are at the European level. But not sure to understand the second question. So you mean by people moving in the cities, there will be more abandoned land outside? Okay. I see from the agricultural viewpoint, I see more intensification. Maybe in the forests, there is an increasing amount of forest, and not only in surface, but in biomass. This is true. I mean, it's a socio-economic change that but it's not only recent. It's since the 19th centuries when people start to migrate, they abandon their land. Yes, I mean, it's difficult to deal with. I mean, this is really space for interdisciplinary project in terms of someone look outside, someone look inside cities. but I mean, I'm a bit reluctant to compare cities with outside cities. This was the approach in the 60s when they compared Swiss cities with pristine habitats, and always showing that cities are bad. But yeah, but I see that your question was a bit in another direction, more in abandonment and what we do with that. Yeah, okay, I cannot answer.
I was wondering if in your work you are also considering the broader scale impacts. So in terms of homogenization, you can achieve very high local biodiversity, which is often true for many urban areas. But then the issue is that cities tend to then have the same set of species all over, and this goes under this concept of homogenization. And is there a way you think it is possible to address this? So maybe working on different people perception and so diversifying the biodiversity from city to city?
I mean, when I realized that this homogenization issue was also related to an epistemological aspect, I mean, studying homogenization starting from the rural pristine to the cities is not fair. I mean, I would like to do it with comparing meadows and forests. I'm sure going from an ecosystem to the other, you will lose some species. You will have winners and losers. I think much more, and I see also the tendency, the trend among urban ecologists to work within cities. So, and to have this ecology, two cities and 4 cities, and to minimize or mitigate this homogenization, which I mean is a characteristic of this ecosystem, is to maximize the diversity, and but also I think is a matter of methodology. I mean, people tend to study one habitat per time. So green roofs, then you go for green roofs. Parks, you go for parks. But what about the mosaics? The effect of mosaics, not in terms of just an index of the heterogeneity, but also what type of habitat, are there a combination of habitats that are dealing with where more biodiversity will emerge? Animals often move, and they move also through ontogeny, so they need as larvae some type of habitat, as adult some other type. If they have to move too long distance from larvae to adults, this is not positive. If you have your adult habitat close by, then it's fine. So also the configuration where these habitats are is important. I think we need both diversity, but also maybe also methodological, more appropriate approach to understand this.
We have one more question here, and then the last one, I think.
Thank you very much for this exciting and stimulating presentation. There was a presentation yesterday by a medical doctor who showed that it has been proved, documented already, a direct interaction between the time people spend in green areas, even if they live in cities, and health problems in, say, heart condition, different types of heart diseases, blood pressure, depressions, behavioral problems, and so on. I think this is a very important fact. Amount of knowledge that we've gathered already, although this line of research is still at the beginning, but that you can use to influence politicians. A lot of studies have also been done at university campus, and it's the same. The conclusions are similar. Students will have a better performance and better marks at the end, and so on.
To me, it's also a matter of being educated. I mean, 80% of the people live now in cities. If we can make them experience a true nature and not or understanding processes, a garden is really a nice open air lab where you see interaction working, not just in books, and end up with fruits, with vegetables. If you have a pond, you observe fantastic stuff. And then this translated also in your perception and your decision when you go to vote or to understand more complex aspects. Everything is not abstract anymore. You have experienced this, and I think this is also a positive effect.
Okay. Many thanks for presentation. It was very inspiring, and
thank you.
I was wondering when you explain all these kind of gardens in Zurich, if there is any similar study in more Mediterranean areas, places where water is really a scarce resource, because I was wondering and why this kind of activities cannot be done when you have very little water, for instance. No?
Mm-hmm.
And so in those cases, even if people probably would like to do that, there is a limitation from the ecological point of view, climate in this case,
mm-hmm.
but also a cultural thing. I think the difference between the cultures are right, probably widespread.
Mm-hmm.
So you said that in Switzerland, everyone wants to have his own piece of land.
Mm.
For instance, where I live, the common lands are the most of the surface of the region are common lands, and there are small villages that have a common land. And
Okay.
in some places, if you are the last inhabitant of that land, of that village, all the common land is yours.
Okay.
But
Yeah.
this is happening now with the decrease of demography.
So, related to research in more Mediterranean area, I mean, you are here in the best place. I mean, Lisbon has long tradition in urban ecology, and see some colleagues here that studies Almada or Lisbon, and in the same way I'm studying. Maybe they have more expertise in other organisms, but and we are sharing currently a biodiversity project comparing different cities across Europe. And water, I mean, yesterday we had a nice talk about water, more marines, but of course in inland you don't have marines, you don't have coasts, but you have rivers, and often these cities have developed along rivers and along lakes, which are, again, very high hotspot of biodiversity. And I would say that most of the Mediterranean cities have also built on rivers, because in the past were like the main trade way to transport stuff and so. So there is water, but maybe not in a mass as one expects. But also the fauna will be adapted to this. I mean, maybe I would this is a guess that in Central Europe, the filter from a species to come to cities is based mainly on resistance to droughtness, so tolerance to droughtness. Maybe in a context where it's already dried outside in the species pool in the regions, this is a less a problem. I mean, maybe you might have much more species living outside, also doing good well in cities, because they are a bit more dried, but it's also dry outside. But this is just a guess.
Okay, so sorry we need to finish, so let's thank again to Michael.
Hi again. So it's me again. Get used to it. So, the participants going on tours have lunch included. You only have to pick it up at the C6 building and be here in the check-in desk by 2 p.m. Okay? So you can be put on the buses. So we now have, we are a bit late, so everything is going to be delayed 15 minutes. Okay, so don't worry, there'll be time for coffee break. and time for enjoying the sessions. Don't need to run and rush and get lost. No need for that. And now we have a short presentation, very short, flash talk by François Massol. Sorry, Professor. Professor was going to present this.
I think I'm not going to present. François Massol is here representing PCI, and more than me, I think that he will explain what is PCI and what it can represent for all of us that are researchers and need to be and need to have published papers. So please, just a few minutes before coffee, and then you can leave and profit your coffee. Thanks, François.
This one? Either. You present from here? Yeah. Oh yeah, if you will. If you want to. Okay. Sorry, I had the other one. Okay. So it works? Yeah. Thanks.
Okay, hello everyone, and thank you for the invitation and the opportunity to talk. So I'm not going to bore you very long. It's going to be fast, so oh, thanks. Thank you. So it's going to be like 5-10 minutes. So I want to present to you today PCI, so Peer Community In, which is a quite new initiative that was funded by these guys, so Denis Bourguet, Thomas Guillemot, and Benoît Facon. And we are in the exhibition area if you want more information. So the what is about PCI. It's an initiative to create communities to review and so evaluate and recommend preprints. And at the moment we have 5 PCI. So we have evolutionary biology, ecology, paleontology, and anthropology and animal science. So the PCIs are all free for authors, readers, so it's basically diamond open access. And the idea is not to actually publish the text. The texts are preprints, so they're already somewhere, but to publish the recommendations of the text, so actually why you should read these papers. So it's kind of different from traditional journals. It's not really a journal, it's more like a reviewing initiative. So why did we do this? It's because there is a lot of value in publishing articles. So it makes things public, it ensures the quality of science because it's peer-reviewed, it defines the entirety of the results, it makes the articles findable, and it's an archive for the future. But we know, I mean we all know in this room probably, that it's a very inefficient system at the moment because there are a lot of submissions and rejection in cascade, which in the end amounts to a lot of time between the time something is finished and the time it's published. And also with traditional journals, most of the time it's not very transparent in the sense that you don't, the reviews and decisions are not for the public, and the editor is not always known, and for the readers, you don't know why a paper is accepted or not. So this is also the why, but it has most link to the publishing industry. So the publishers actually, the publishing industry is held by 6 big publishers. And well, I think you all know that, but the profit margins of this sector are so huge. I mean, it's an indicator of how insane the system is. Like Elsevier, for instance, has a profit margin that is double of the Bank of America. So you have to imagine exactly how, I mean, the amount of money that these guys are making out of us, actually, because we are actually doing the writing, evaluation, editing. I mean, everything is on researchers. So there is There is a problem with traditional publishing, but so now we got a lot of preprints out there, which have a lot of good points, lots of qualities, like it's free for authors and readers, it's available immediately, etc. So it's archived, there is almost everything in preprints except peer review. So the idea with PCI was to actually peer review these preprints, because it's the one thing that is missing to actually reappropriate the publication system. So how does this work? So it's kind of easy. So you have your work already written somewhere. I mean, you have it written on your computer. Then one thing you do is you deposit it on a preprint server. So it could be any server, actually. I mean, we don't mind, as long as it's a permanent preprint server. And the second step is to actually submit the DOI or whatever link you have of the preprint to PCI. And so you can choose among the 5 already available. Say you actually submit to PCI Ecology, and then you select a number of editors, so we call them recommenders. And if one of them actually pick up the paper, then there is the preprint is going to be peer reviewed. And so there's going to be a number of revised versions that are, I mean, in between the discussions with the editors, the reviewers, and then sent back to the authors. And at the end, if the paper is actually accepted, so it's called recommended, then the recommender, so the editor, actually writes one page of recommendation, which says why people should actually read this paper. And we link the last version of the preprint with the recommendation. So if one stumbles on the paper or on the recommendation, one can also find the other one. And also we attach to the recommendation all the reviews, so all the reviewing process. So that's completely transparent for the public why this paper was recommended. So as I said, we don't mind about archives. So I mean, the big ones, archives, bioarchives, or Zenodo, are well known, but actually we don't mind. I mean, all of these are also valuable. I mean, as long as you want your paper to be somewhere and you trust the somewhere to be permanent, well, we don't mind. It's an archive depository. So at the moment, as I said, we have 5 instances of peer community. So the oldest one is evolutionary biology. And then paleontology, ecology existed for more than 1 year. And very recently we had entomology and animal science that were created. So all of this is already available, and we are looking for more. And for people that actually want the paper in the end to be published somewhere in the traditional sense, so we are not against the journal, and not at all. So the thing is that when it's actually recommended at one of the PCI, the idea is that all the reviews are mobile. I mean, you can take them and send them to a journal. And so what we did was ask the editors of a lot of journals what they thought about PCI and whether they would be PCI friendly, in the sense that they would value the recommendations and use them for handling without peer review if they thought that it was well done. And this is a sample of the journals that said they are PCI friendly. So if you, for example, if you were accepted, I mean, if you were recommended at PCI Ecology, you could send it to Oikos, and maybe that would work easier. But actually, the good thing is that once you have the reviews, you can send them to do several different journals in a row. I mean, if one is not happy with the scope of your paper, then you can send them to another one. And we also have a lot of institutional support from different societies from so the French, the Nordic, etc. I mean, and the SPECOs, and we have support from different institutions like INRA and CNRS in France. We have also support from evaluation committee, and that is an important part. Is that if we want to move away from prestige and traditional journals, we also have to be able to change the way evaluation committees work. And we already started to do that in France with the several evaluation committees at the CNRS and INRA and IRD that actually did that. And also the doctoral school, so for thesis, so PhD chapters to be accepted as valid when they are recommended at PCI. So we already started this thing in France, but we are trying to do the same in other countries, but it's not so easy. And so this is the timeline of PCI. So it started in 2017 with PCI evolutionary biology, then the year after with paleontology and ecology. Now we got these 2 ones. Genomics is coming in the next months, and then we will have one in neuroscience, and we are discussing forest science and mathematical and computational biology. And the long-term discussions are about virology, ecotoxicology, registered reports. So actually, if anybody in the audience wants to start a new one, it's very open. Contact Thomas and Denis. They will sure be very glad about it. So thank you for your attention, and I'll be in the exhibition area if you have questions.
And don't forget that if you have any doubts, François has been all time here and has a stand there.
Thanks.